Hi there, this is Mohammed from mathsbuy.com, and today we're going to be doing the normal distribution and specifically the inverse function and how to do that using your calculator and do questions related to that. So here we have an example, so let's get straight into it. A machine produces metal bolts of diameter d millimeters where d is normally distributed with standard deviation 0.1. There's also a probability statement there, and the question is to find mu, which is to find the mean. So in the question here, they've defined the variable as d, and it says here that d is normally distributed, and they have given us the standard deviation. So we can define our variable here. D is normally distributed. The mean is unknown, so we just put it as mu, and the standard deviation is 0.1. So here we put in the variance, which is 0.1 squared. So let's go over to the probability statement that's been given here. So they've written here that given that 5% of bolts have a diameter in excess of 5.62 millimeters, we can turn that now into a probability statement. And that tells us that the probability that D is greater than 5.62 must be equal to 5%, which is 0.05. So at this point, because the mean is unknown, we're definitely going to be using the inverse function on the calculator to try and find the mean. So there's a couple of things that we need to do before we can use the inverse function on the calculator. We're going to need to standardize this statement because we don't know the mean. Also, we need to change the statement to a less than. Now that's really quite simple. If you have a greater than statement and you need to use the inverse function, it has to be in the terms of less than. And I'll show you why when we get to the function. So quite simply, you can change that to a less than, and the probability that will go here will just be 1 minus the probability here. So that's going to give us 0.95. I'll demonstrate that in terms of a diagram. So in our curve here, this initial probability is represented here. So 5.62 you would say is over here, and the reason I would position it here is because the area which is given as a greater than is fairly small, and the area given is 0.05, and so that means quite simply that the area to the left of this point here must be 0.95. And that's how we get this second statement here. Okay, so continuing from here. So we've changed it to a less than statement, which is essential for the normal inverse function to be used. We also need to standardize, so I'll show you why on the calculator here. When you use the inverse function, you want to go through menu, and then number 7 for distribution. And here you want inverse normal. So the area has to be in terms of a less than statement. Now we've done that, so the area here would be 0.95, and you may think, okay, we've got the standard deviation, it's 0.1, but then here's the problem, we don't have the mean. So what are you supposed to put here? The whole point of this question is to find the mean, so using the inverse function at the moment is not possible. This is where you would have to standardize the probability statement that you have. So the standardization process goes like this. We change the probability statement, instead of D, we're changing to Z. And here, using the standardization equation, it will become 5.62 minus mu, that's our unknown, so I fill it in as mu, over the standard deviation, which is 0.1. And that will still be equal to 0.95. What we've used here is a standardization formula, which is Z is equal to whatever your variable is, x minus the mean over sigma. So the reason we've done this is now that you're in terms of Z is normally distributed, and the mean is set at 0 and the standard deviation is 1. So that allows us to now use the calculator using Z, knowing that the mean that we can input into the calculator is 0 and the standard deviation is 1. So let's just go through that again. So now that you've standardized, you can now use the inverse function. So going to number 7, inverse normal number 3, the area is 0.95, and that must be the area in terms of, or the probability in a less than statement. The standard deviation is 1 because we've standardized, and the mean is 0. So pressing equals here, it gives us a value, 1.6449 to 4 dp. And I'll show you what that actually means. That means the probability that Z is less than that value, 1.6449, is equal to 0.95. The calculator, the value it gives you is always in terms of a less than statement, which is exactly what we want. So now by direct comparison, we can deduce that this expression here must be equal to 1.6449. So let's just write that out. And from there, it's a fairly simple rearrangement. And we can get that mu must be equal to 5.4555. So I hope that's helped in terms of going through a simple example of how to use the inverse normal and when you would use it. Remembering in this case that mu was unknown, that's the key to this question, is that you would have to standardize, and it would be the same if sigma was unknown, and perhaps we'll see that in a separate video. So any question where the mean or the standard deviation is unknown, you should be able to follow this process that will then lead you to an equation that will involve either your mu or your sigma, or your mean or your standard deviation, and then you should be able to work them out from there using that. But obviously the key, as I just said, is to standardize so you can use the inverse function, and when you standardize, you get that the mean used in the calculator will be 0, and the sigma used for the standard deviation will be 1. So thanks for watching. Don't forget to like and subscribe, and see you on the next video.